Hi, very good morning to all of you. I'm Dr. Kumar Gaurav, Associate Professor in the Department of Earth and Environmental Sciences, Indian Institute of Science Education Research, Bhopal. I'm told that I'll have to just engage you for 2 minutes because presentation is not uploaded. Now I'll do that. So, previous speaker he was talking about the technology enhancement and the regulation, all those things. That is very good. But as an user perspective, what I think is that okay, drain technology has evolved. Companies have been working in this field for last 1 decade or two because the first drone which I was introduced in early 2012, so it has been more than 10 years. But still, when we procure drones from vendors, companies, when supplying spare parts, they always complain, sir, our drone technology is still in India, it's still at initial stage. We cannot give you a spare part, and it takes sometimes more than 6 months. And I'm struggling. I have a drone that I use for my research purpose that has gone bad to get. While when it comes to selling, they'll commit everything. But when it comes to providing spare parts, they don't, and which is very painful. I know for industry, 10 lakh bucks, 20 lakh rupees is nothing. But for a researcher, it's a huge money. When we write to funding agency saying that I want to buy a drone that costs 10 lakh, 15 lakh rupees, they require a lot of justification. Okay, and then we earn that money to buy something. And if that we spend 10 lakh rupees, 20 lakh rupees, if that instrument doesn't work for a year, we are gone. Even if you buy a car that costs you 10 lakh rupees, 8 lakh rupees, that starts from, you get service. And what I have observed, some of the companies, they come into the market, they sell their product, and they'll say, sir, we have stopped manufacture because our that drone was in loss. So I hope all these experts from companies, technicians from companies, they'll yeah yeah. So they'll think about it. And as a user, what I would like to do, I have money and I would like to buy a space, and it should be ready to deliver at any cost. So this is what with that I just want to speak you as a scientist what I do. I'm not a developer of drone, but I use drone data for my research purpose. As in the beginning introduction, it was I'm an earth scientist. I work on rivers, so different type of river, and I'll start what exactly and how much work you can do by using drone data and how efficient these important these data sets are. So, as a user in application domain, I cannot think where drone cannot be used. If you see, drone can be used for all purposes in every application domain. So, what I am interested, as you can see here in this slide, I think, yeah, pointer is not working. In this slide, just to show, drone can be used for multiple tasks. I am interested in river, hydrology, flood. So I'll give you an example. I'll give you an example. So most of the time, policymakers, engineers, they are interested in gauging river. Monitoring river, how much flow is taking place at a given time is a challenging task. In situ measurements, we are doing at sparsely located points where CWC, Central Water Commission, they are recording, they are monitoring river. But from the physics, we know that the scaling relationship, so if y-axis is width, x-axis is discharge, and this holds a power law relationship. So width scale as a square root of discharge, that we know. And the prefactor coefficient depends upon many other parameters. But the important thing, this is a theoretical, this is not a empirical equation, this is a theoretical. And what you can see that even the coefficient for the entire Himalayan system, even the coefficient for entire Himalayan system is same. So the entire Himalayan river can be modeled by using a single equation. And this equation is represented by this solid line. The data points that you see is diverse from Ganga, Brahmaputra, Yamuna, Kosi river, from the entire Indo-Gangetic plain. Now, the idea is if this relationship holds true, what I can do, I can go to the satellite image, measure its width, and then I can predict discharge. I do that. So for that, I have developed algorithm which was funded by Ministry of Earth Sciences. So I take a binary image of infrared or red band, anything I can take, and then I can process. So starting from thresholding, identifying the isolated pixel and a skeleton, and then width calculation. So I have width everywhere, okay, and then I can use that width to predict discharge, because as I told, I don't know, many of you might be knowing, river, especially the river which flows on the sediment, loose sediments, they have variable width. So that was also a challenge, which width to consider. So therefore we did some statistical analysis to get the width. Now once you have this width, you can predict discharge. That we have done. We have written several couple of papers that I'm not showing you. But the most important, because this talk is related to drones, so where drone can help me. So this is a famous river Kosi, which flows. This is the upstream. This is the downstream. So now at one is it's about 80 kilometer. In 80-kilometer length, CWC has two gauge station. One gauge station here and another gauge station here, which is shown in red. Now, so you have high discharge. You have relatively higher discharge as compared to the downstream. But we know that rivers are in Ganga plain, most of the rivers are gaining river. Gaining rivers means when you go down, discharge will increase. But here it's decreasing. So as I told you, according to my algorithm, I measure width everywhere, and then I have plotted the data. Interesting thing, what you could see, that discharge increases and something happened in between and discharge decreases. So I am able to get some sort of trend. But here what is happening? So though river is gaining discharge, but what is happening? It could be because of the over extraction in this region, because of agriculture purposes or what. So I am losing something, so I know. But if you see here, the variability is very high. It's about 1500 cubic meter per second. This variability is coming from the measurement uncertainty that I get from satellite images. Because if I make 1 pixel error in one side, so let's say I'm using 30 meter of Landsat, it will have uncertainty of 60 meter in my measurement, if I'm lucky enough. But in these cases, you can have uncertainty about 10 to 20%. Okay. So here, if I use drones, so drones can give me millimeter resolution, and therefore these measurements can be tightened. So drone can help me here to reduce the uncertainty that I have in my measurements. Now I'll give you another example. This is the digital elevation model, where digital elevation model is when you have height information that is required for many of the hydrological modeling. So this digital elevation model is publicly available. That was from Astra GDM, that takes images from 2000 to 2013, and they use some sort of machine learning algorithm to come up with the digital elevation model. They claim that they are updated. Another digital elevation model which is in public domain was constructed in 2000, which is SRTM, Shuttle Radar Topographic Mission. Now if I use this, so this is an area of Ganga river, this is Narora Barrage, and this is the upstream of Narora Barrage. Now if you see, in digital, when the digital elevation model was acquired, river has two streams, threads. Now 2020, what happens? Now river is flowing in one thread. All we know that these are mobile rivers, they keep on changing their position. Now if this is true and somebody is using this kind of digital elevation model to do hydrological analysis, you will end up in a wrong result. Now if we all agree, then what I did, so because I wanted to do habitat modeling. So habitat modeling, river provides habitat to many species, and that habitats is some species preferred some flow depth, some velocity, and channel width. Can I do that by using some sort of remote sensing and images? So what I have done, okay, sorry. So here, what I have done, I flew a drone, and by using drone, I acquired data in LiDAR. Okay, so LiDAR drone, and then we have constructed for this small reach. Okay, because this is very expensive. With drone, we cannot fly very high. So we created a digital elevation model, and now with this digital elevation model, we had a very precise, and then I can integrate this digital elevation model by using some in situ measurement that is called bathymetric measurements, and then I can apply hydrological modeling that I did, and as you can see here, we have predicted flow depth along the river, velocity variation along the river, and if I compare with the measurements, as you can see here, our prediction is not so bad. It's good. However, the uncertainty here again, because this is a time series. So, digital elevation model represents some time. If I have several digital elevation model, perhaps I can get rid of this uncertainty also that you can see here in the lean flow. So, this is one thing where drone technology is very useful and I am using. Another example I would like to highlight, a study which I am conducting. So, human perturbation, people or government of India is interested in floodplain zonation, where you will have no-go zone, regulatory zone and all those things, and there we don't have much guideline. There is a thumb rule say that, okay, you go 30 meter both sides of the river, should not have any construction, but no, that is not scientifically sound. So I'll just give you an example why it is important. This is a river. So as you can see here, this red box, the entire image we have taken by using RGB drone images, and then by using that photogrammetry we have calculated digital elevation model. And interestingly, what happens, there is a human perturbation here. They had started doing mining, and because of this mining, what happens, the drainage has evolved, and now you can see here there is a stream which has originated and going into the river. So what it is doing? So you are creating a channel, kind of gullies, and then you are initiating sediment erosion, and that erosion is eventually will affect your floodplain. If you have somebody has created house here, that will wash, and this is what we see when extreme rainfall occurs. So we get either sometimes we get waterlogging, sometimes we buildings get collapsed. It's only because you are constructing on the river path. Okay, so this is one thing that where drone can help you a lot, and we are doing this study. Now, one thing is people are interested in human perturbation. We are mining. We are doing mining. So mining, how much optimal mining? So there is, according to the government regulation, optimal mining is required. People they do more than that. So this is an example where excavation was going on. I flew some drone and then created digital elevation model. As you can see here, this is so fine resolution. Okay, and now this yellow line is the elevation profile that was taken by SRTM in 2000, and this red line is the profile that we generated by using our drone digital elevation model. And as you can see here, how much topography has changed. So by using this, we can continuously monitor how much excavation has taken place, how much, or if you have some regulation, you can check that. Okay, so that can be done. So this is one thing where we are working on. And another thing that I would like to give you an example, because government and particularly in river rejuvenation, people are talking about the sand mining. So sand mining, there is no estimate how much sand has been mined, what is the frequency, but drone, if you could fly drone, you can count number of vehicles, their size, even all these mounts, and you can calculate how much volume is accumulated, how much volume is being mined, and so on. So all these things are very important because government generate revenue. If government will have good information, they can save money. And also, excessive mining can be dangerous for river health also. So all these things can be monitored. So these are the few examples which I have showed you, and there are many in which my research group we are engaged in. So this is a glimpse what I do. I wanted to give you. Thank you very much. If you have any questions, I will be happy to answer.
Dr. Gaurav, thanks indeed for a very insightful presentation, and it has been a revelation to me, and I didn't know that this kind of knowledge is available within India. Now, in the background of the recent bursting of the dam which has taken place in Wayanad, and we lost about 400 plus lives. And there are two ticking bombs there in Kerala, the state which I belong to. Mullaperiyar Dam, which is constructed 127 years back. People are really scared, and there are, people, the doomsay is saying that it can burst anytime, etc. Now, using this technology, now I understand it is quite possible. You can work out different scenarios and models with, the level of the water, that means the complete volume of water, and if it flows out in a certain number of hours, etc., etc., what will be the flooding and which all areas will get submerged, all these things. I personally request you that you should actually, put out this in the public domain also, and the state governments particularly should make use of this information, and they should also do the planning for disaster management within their states. Thank once again. Thank you.
Thank you very much. Yeah, I think.
Thank you for the presentation. So, a couple of questions. One, to sense the actual flow, do you take a sampling at a frequent intervals, or do you really have to fly the drone all the way, all the length, and do a measurements of it?
Yes, so that depends upon, as I told you, we integrate. Sorry, as I told you, we integrate things. So because to develop that curve, we fix a location, okay, of reach of a river, not one point, and let's say 2 kilometers of reach. So in 2 kilometers of reach, we are flying drone, and simultaneously we are making some in situ measurement. For example, bathymetric survey.
Okay.
And once we have sufficient number of data sets, then we try to generate a relationship with discharge or a stage discharge relationship.
Okay. The second question is, instead of LiDAR, have you looked at the IR, infrared imagery for that? Because there are some algorithms currently we work with on some of our platforms, and the LiDAR seems to have a much better accuracy previously, but now with all the advent, the IR images actually has a kind of getting close to it, and the IR imagery is also much cheaper with the drone. And so then I have one more question, is that when in your study, from the banks, how far off you would go? Is it a couple of kilometers, or how wide? Because sometimes the extraction points is probably not just next to the bank. It could be a long-lasting effect on it.
Yeah, so your question is the size of the width of the river. So that depends. For example, Narmada River, if you are working in central India, the width is order of 500 meters. But the Kosi River, where width can be 6 kilometers, 7 kilometers across. But the problem with the Kosi River or many of the Himalayan river, there are two type of river. One river is just flowing single channel. Another river, for example, Kosi and Brahmaputra, you have multi-thread system. So each thread itself is a channel, isolated channel.
Okay. Yeah, thank you. We have some models, and we can actually discuss offline.
Yeah,
and
that would be great.
I share the concerns about the Wayanad, because I personally, I have an office next to the Wayanad where this happens, and it's a lot of our employees are affected in Calicut. So I just share, and it's great to see that there are some researches done. And we have some models, and we have a platform, and happy to collaborate or do anything. Thank you.
Thank you very much.
Here again, Captain Chawla. Sir, I just want to have information, rather I am not that much educated as you are, Dr. Gaurav. What is the correlation between the satellite imagery and your drone picture? How you correlate with all this data?
Okay, sir. So one correlation I have already shown is if you are comparing digital elevation model. So in digital elevation model, vertical accuracy so there is some uncertainty that depends upon the resolution. But if you are comparing in 2 dimensions, so for example, publicly available satellite image where 1 pixel size represents 30 meter. Okay, and here in drone you have millimeter. So if you are classifying the band, so with that also we can do, there are some algorithm, for example, subpixel classification, all those things. But here, since we have millimeter resolution, so the measurements are much accurate.
Okay, thank you.
Thank you very much. So I don't do you have any questions?